I'd like to tell you all a story about people, a story about loss, and a story about triumph. It will see moments of joy turn to moments of sadness, but out of that sadness will come hope, and eventually, life. This is the story of a small, forgotten satellite by the name of Oscar 7, the little satellite that could. To start off the incredible story of the oldest operational satellite in the world, we have to take a trip back to the beginning, back to where it all began. Early in the 1900s, wireless communication was seeing itself having a massive uptick in use and demand. Just 1 year after the turn of the century, in 1901, some guy called Marconi used a bunch of other guys' ideas to send a signal across the Atlantic. Not a single person back then had TikTok, nor Instagram, so naturally, everybody went absolutely crazy over this technology. Send my brothers overseas a hee-hee over the telegraph with no wires? You don't say! As this technology rapidly grew and began to flood the consumer market, the interference and noise from these newfangled radio waves was starting to become a problem here in the US. It would become such a problem, in fact, that radio interference would delay and hamper rescue efforts to a certain ship many of you all know, the Titanic. In response to the Titanic sinking and the compounding interference issues, in 1912 Congress would draft and approve the Radio Act. This would allow government control and regulation of all radio transmission sources, including consumer uses. Even with this control and authority, the United States government would allocate wavelengths under the 200-meter radio spectrum to an amateur classification, still allowing free, albeit with a license, communication with others. But there was one little issue with this situation. Transmission distance on these bandwidths was short and limited. Mr. Transatlantic wouldn't be able to talk to his brother, at least not for free, and not for now. 2 years pass, and in 1914, Herr Percy Maxim, and no, not that Maxim, would figure out that even with these bandwidth restrictions, a series of chain-linked radio towers, or repeaters, could provide back-to-back coverage all the way across the nation. This would indeed be implemented, and Maxim himself would found the American Radio Relay League, or ARRL. Mr. Transatlantic was happy he could talk to his friends, but he was still a little disappointed. "I know it's great, Eleanor, but my brother's all the way across the Atlantic," he would say. "By golly, I just wish there was a way." By 1927, though, Mr. Transatlantic would finally have his wish, when, at the International Radio Telegraph Conference held in Washington, D.C., the government would allow for amateur radio use on HF or high-frequency bands, making real-time, around-the-globe communication possible. At first, this would be in Morse code, but in the 1950s, modulation advancements during World War II, combined with the surplus military radio equipment after said war, would see high-frequency voice communication widely adopted in the United States and the world. This was really the first social media, or networking as we know it today, and while you couldn't FaceTime or send silly GIF images, it was still like nothing the planet had ever experienced before. Friends could hit each other up from vehicles while on the move. The equivalent of large chat groups consisting of hundreds, if not thousands of people could be found in cities. And, of course, Smokies could inform one another on those bandit locations. In time, it started being called ham, named after clumsy, ham-fingered Morse code operators, and got its association from amateur hams jamming up commercial signals in those early days. Safe to say, the name stuck, and ham radio was born. And ham radio, well, it was a hit. While ham radio was a success and had become a worldwide phenomenon, one small issue remained, that dang ionosphere. HF radio users use a method known as propagation to send their signals long distances, bouncing or refracting them off the Earth's ionosphere. The problem arises, pun intended, when the sun comes out and raises the density of the ionosphere, limiting most amateur HF ranges drastically during the daytime and increasing them at night. As well as this, line of sight to the bounce waves was still required. And while the radio waves still did have some spread to them, this meant that terrain features such as mountains or large groups of buildings could block the signals. Fast forward 10 years or so to the early 1960s, and the space race has hit the ground running, seeing the public Sputnik, Pioneer, Explorer, and Luna missions all being launched with some success, along with various spy missions making it to orbit. Being already radio and tech savvy, a man, some would say a dapper outdoors man, named Donald Stoner had an idea. We have solar panels, we have rechargeable batteries, and we have small, low-powered transceivers now. Why don't we just put the repeater in space? He then politely proceeded to ask if anyone had a spare rocket by any chance. To my utter disbelief when researching this video, Donald Stoner got his rocket. Well, part of one at least. I'd like to preface this by saying we do not know exactly how this interaction took place, as sadly, Donald Stoner passed away in 1999. But it went a little something like this. Stoner, shortly after proposing and talking about his ideas for a small ham radio satellite, got a reply back. This reply happened to come from several members of a certain group called the Lockheed Amateur Radio Club, employees and hams of the famous Lockheed itself. They would offer him some space on an upcoming launch, an offer he just couldn't refuse. With this gracious offer accepted, Stoner and Mr. Lance Skinner, the man who constructed the satellite, got to work, naming their little creation the orbiting satellite-carrying amateur radio, Oscar. Oscar 1 would be launched on December 12, 1961, being stowed in a bit of free space beside Discoverer 36, or, as it would be later revealed as, the final Corona 9029 spy satellite, marking both the end of Corona and the beginning of Oscar. As the Oscar program grew and gained international attention in the amateur radio space, collaboration and coordination became ever more of a problem. To combat this issue and provide support to the Oscar program, the Radio Amateur Satellite Corporation was founded in 1969. AMSAT was born. By 1970, they would launch AMSAT Oscar 5, or AO5, being constructed by students from the University of Melbourne in Australia. In 1972, their first long-life satellite, AO6, took to the airwaves. And now, we come to November 15th, 1974. And finally, our story begins. The Sleeping Beauty satellite, Oscar 7. So, before we see what makes Oscar 7 tick, I'd first like to go over a quick note for new viewers of the channel. Here on Retro Rockets, we take a deep dive into what devices and technological impacts these craft had. So if you're not as into the fine details and just want to hear what happened to little Oscar 7, I've added chapters and timestamps below, so feel free to skip to that and check out AO7's incredible story. Alright, now that they're gone, let's get into it. So, there's not too much going on with Oscar 7 compared to my other videos, so this will be much more condensed and to the point than those tend to be. But, this is Retro Rockets, so you know we're gonna have to dive in anyways. Launched on some fancy shrouded Thor, known as, wait, let me check this, the Delta 2310. Okay, so apparently the version of this rocket only had 3 launches. Well, that's gonna be hard to find footage for, so here's some photos instead. Oscar would be hitching a ride with the NOAA 4 weather satellite, alongside another fellow microsat, the Spanish-built Intelsat. After being booted out of the way by some pyro pins and one fancy spring, Oscar would start doing his thing. He would cost a whole $38,000 and see him having a planned mission life of just 5 years, something he would go on to far exceed. Being built in a basement, AO7 weighed in at around 64 pounds, or 29 kilograms, classifying him as a small sat, or microsat. He would consist of a 14 by 16 inch octahedral frame made from aircraft-grade aluminum. He would house 2 linear transponders, 4 radio beacons, 2 redundant telemetry systems, and a quite advanced data storage system, and 1 infamous battery. It was made up of modules that were built by ham radio and AMSAT members from all around the world, including Germany, Australia, Canada, and of course the United States. Did I mention it was made in a basement? Yes, sir, that's right. The USAO7 team who assembled Oscar did so in a basement. Well, more like all over this particular house. You can see how their integration clean room is literally just the corner of the room, sealed off by clear plastic wrap. It's pretty incredible how these various teams, some of which consisting of NASA employees themselves, created this satellite from houses and workshops. Even though they had coordination from AMSAT, the budget for these programs were extremely low, and it must have been close to impossible to acquire the parts needed for AO7. But forgive me, I'm getting ahead of myself. In true retro rockets fashion, we'll start with the power systems. Oscar 7 ran primarily on a 12 to 14 volt electrical subsystem. At the beginning of its life, the solar panels that surrounded Oscar's shell could generate an absolute maximum of, wait for it, 14 watts. You really didn't think it was going to be that much, did you? Outputting around 6 volts, and later being dropped to about 10 watts of power. Even when it was at 14 watts, it wasn't a whole hell of a lot. But it was enough. Enough to work. And enough to easily power one of AO7's more advanced features, its low power draw telecommunications equipment. Starting with its transponders, these devices provided Oscar with a means of both detecting, identifying, and converting radio transmission sources, as well as being able to acquire distance information. Oscar had 2 of these in his modularized frame, one Mode A and one Mode B. The Mode A transponder for AO7 was capable of taking in a 145.85 to 145.95 MHz very high frequency waves, such as those used in a handheld radio, and repeating this as a lower frequency 29.4 to 29.5 MHz signal, extending the radio wave and drastically increasing communication range. The next transponder, Mode B, was very similar to the Mode A transponder, but being a UHF or ultra-high frequency to VHF transponder. This device ranged from 432.125 to 432.175 MHz, and VHF from 145.975 to 145.925 MHz. While being similar in function to the Mode A, the Mode B transponder has a little bit more going on to it than meets the eye. And I mean, look at it. That's saying something. This little handmade beauty was the creation of a Dr. Karl Mainze. He was part of the AMSAT Germany team and would craft both of AO7's transponders. This was all well and good, but Karl, in true AMSAT fashion, Karl was up to something. The gears in his ham radio brain had begun spinning, and once they spinning, they don't stop. After all, he did have a PhD thesis he had to do, but we'll get around to that. Over time, Karl would devise a process that would highly increase the efficiency of this transponder, maintaining high performance while still keeping power down to an absolute maximum of 8 watts. Karl had done it. With off-the-shelf components and his electronic wizardry, he made it work. Karl's PhD thesis was complete. Or so he thought. But again, we'll get to that in time. Safe to say, Karl had created the HALP system, or High Efficient Linear Amplification by Parametric Synthesis. And even though its name is quite the mouthful, this system would be revolutionary for spacecraft to come, with this technology going on to see power efficiencies of up to 40%, and still being used to this very day. Next up is Oscar's 4 radio beacons, and due to international treaties, it's more like 3. With its 13-centimeter beacon seeing it disabled unless used for emergencies. All of these beacons would be used to locate and track AO7 while he traverses around the Earth. These beacons transmitted on the 10-meter, 2-meter, and 70-meter radio bands, and they would be key for ham operators to keep a lock on Oscar 7's location. These radio beacons would also be instrumental in broadcasting out Oscar's next bit of kit, his telemetry systems. Now you might be thinking at this point, damn Ben, that's a hell of a lot of stuff already for a small little radio satellite. And you'd be right. The makers of AO7 crammed this thing jam full of stuff. As we keep going through the various tech on Oscar 7, not only this, but the craftsmanship and attention to detail these teams put in will become very apparent. Getting back to the telemetry, AO7 had 2 of these systems, and both would be used to gather digital information from Oscar. The first one of these was the Morse code or CW system, being short for continuous wave. Just like the Morse code system of the past, this would send out pulses or words as it's known, back down to Earth. Morse was very, very slow, but due to its simplicity, this system allowed Oscar to become an educational tool for hundreds, if not thousands of schools and radio groups around the globe. Next is the RTTY, or Radio Teletype Telemetry System. This method of sending data was orders of magnitude faster than its Morse system, and would allow Oscar to send back information at a still impressive 2.5 kilobytes of data per second. The physical device itself would consist of over 100 hand-soldered CMOS integrated circuits, being the handiwork of two gentlemen from Australia, showing us just yet again how Oscar, and all of his kind, are created from people around the world and from all walks of life. Both of these telemetry systems would also feature a start and end message for those on the ground to distinguish between packets of data. The message? Hee hee, with Oscar laughing just as Mr. Transatlantic used to do all those years ago. The next two modules on Oscar go hand in hand, and those are its command system and its experiment control logic, or ECL. As far as its command system, unlike the hundreds in my previous Surveyor video, Oscar had a total of only 35 available commands, but seeing as it's not a 60s automated moon drone like Surveyor was, I think he gets a pass. These command systems would range from radio gear switching down to powering systems on or off. However, even with this command authority and flexibility, much of it was not needed. For you see, even before the modern microprocessor, A07 could command itself. This feat of early computing would be accomplished by the ECL. Created by none other than our PhD man Carl himself, the experiment control logic on Oscar was a marvel of engineering. It would allow Oscar to control and even restart his own systems completely autonomously, with no power-based memory, and needing no human intervention whatsoever. Speaking of that, another thing Oscar could do on his own was store data. This data could be stored, saved, and then replayed back all the way around the world. Again, well before the 8-bit microprocessor, this module would make up the last remaining compartment on Oscar 7. Its name? Project Code Store. Code Store was the brainchild of a Texas man by the name of John Good. Comprised of 14 chips, each memory-based integrated circuit could hold 64 bits of data, making for a grand total of 896 bits of precious data storage. It wasn't much even for 1974, but it was cheap, and it was small, and it worked. These types of systems would also go on to become the predecessor to our modern packet-based systems of today. Moving on, and yes, we are almost done with the systems, but fear not, faithful viewer, I've saved the best for last. We'll start with the magnet. Trust me, we gotta talk about the magnet. Well, 4 of them actually. You see, without an RCS, or reaction control system, Oscar wouldn't be able to orientate himself, weeblin' and wobblin', but never fallin' down. To counteract this, the AO17 placed 4 strong, yet small, magnets on certain places around Oscar's frame. The stabilization process was simple, yet genius. Using these magnets in exactly the right way would allow Oscar to straight up just lock onto the lines of the Earth's magnetic field. Yep, because of Oscar's size, and this completely passive system, he will be constantly stabilized in space until the very field of the Earth is gone. The one last cool thing to mention about Oscar, except for the battery, we'll get to that, was the way he keeps his spin from decaying. We have talked a bit about spin stabilization in my other videos, but we'll go over the basics. On most craft, the induced spin, which is usually imparted from an upper rocket stage, keeps the craft from weaving out of control by using the method of angular momentum, similar to that of a gyroscope. But Oscar isn't just some craft. He's an AMSAT craft. So you know there's got to be more to it than that. In fact, there is. For the AO7 team had equipped Oscar with a Photon propeller. Yes, while sounding like something right out of Star Trek, this is 100% a real thing, and Oscar had one. The way it worked was not only incredible, but actually fairly understandable. Fitted to Oscar's 4 flat turnstile antennas was a layer of white and black paint. This would use the difference in absorption of the solar wind from the sun to keep Oscar spinning. This, in theory, is a solar sail, but used only for spinning, hence the propeller name. But one might ask, well, What happens if you get spinning too fast? As usual, the AO7 team had that covered as well. Using, let me check this again. Yes, a bunch of crazy metal rods. If Oscar started getting too dizzy, these so-called hysteresis dampers would, somehow, convert this spinning torque into heat and absorbing this unwanted momentum. They were tuned perfectly to keep Oscar right in his sweet spot of spin, allowing him to regulate this, again, completely passively, with far too much math and calculating than I can handle. Well, now that we've covered the systems on Oscar 7, it's now time to get to the main star of the show, his amazing revival story, and his oh-so-infamous battery. Join me as we now tell the tale of the little ham satellite that could. That good old Oscar 7 was doing just fine. For 6.5 years he happily relayed greetings and countless conversations. Until one fateful day in June of 1981. Boom. Nothing. Oscar, the little friendly ham satellite, was dead. A cascading series of failures in his 6 amp-hour NiCad battery had cut off his power, rendering his whole electrical subsystem utterly useless. The AO7 team had feared this day would come. Even before Oscar's launch, they were already highly doubtful about the battery's durability and longevity. But, being such a small project in the grand scheme of things, they took what they could get. However, this suspected lack of quality would later go on to create nothing short of a miracle. While being inoperable and drifting powerless through space, something quite amazing would happen to the tiny, unassuming Oscar. Deep inside his shell, another cell of Oscar's NiCad battery failed yet again, drawing power and keeping the connection to the rest of his power system starved for energy. This was tragic for Oscar, but normal. After all, this is how these types of batteries are supposed to fail. But this time, it was different. This time, it had failed the wrong way. A small, very minute manufacturing defect in the battery cell had allowed the impossible. It allowed the cell to fail open, recompleting its primary circuit, enabling its electrical systems, and allowing it to do what no craft has ever done, now nor since. Sometime after this incredibly rare event occurred, an even more incredible one was about to take place. After somehow being influenced by Oscar's use in the Polish anti-communist movement, a man by the name of Pat Gowan would, all the way in 2002, just so happened to give it a shot and try communicating with the spacecraft. To his amazement, he got a signal back. Oscar 7, somehow, someway, was alive. After a full 21 years of radio silence, Oscar would again start repeating things up, just like he had always used to do, albeit with a slight satellite version of a limp. For you see, the batteries of AO7 were indeed expired, meaning all system power from here on out would come directly from its 10 watts of solar cell output. This fact itself would also be a somewhat mini miracle, as when checking the overall degradation of its somewhat cheaper cells, the AO7 team found them to be in excellent condition, still outputting more than enough power to keep Oscar online. One other large reason for Oscar's second life has to do with where he's at in space, his orbit. Oscar is up there, way up there. He stays in SSO, or Sun Synchronous Orbit, orbiting steadily some 900 miles above the Earth. Oscar's been up there, and he ain't coming down until we're all long gone. Other than that pesky, or rather lucky battery, the other lack of degradation on Oscar, combined with his orbit, means that he will continue doing his thing. Of the making of this video in 2024, this November has marked Oscar's 50th year passing through the vacuum of space and connecting people around the world. In addition to his anniversary, he has recently reached a point in his orbit where he will see constant sunlight for the next 3 years. So if you're a ham, make sure to say he. Or is it hi? I don't know, I like he better. Oscar 7, at this rate, will outlive every single one of us, even those born at this very moment. He was built in a basement, out of spare parts, by a team of kind, gifted, and driven people. These people didn't do it for some paycheck, nor did they do it for the fame. These people did it because they wanted to. This is really their story. Like I said, this whole time this has been a story about people. a story about life, and a story about Oscar 7, a little satellite that could. So now that we've heard Oscar's story, we have to ask, how did this happen, specifically and internally speaking? This in-depth look is what's really needed to understand how rare this event was. A07 is still up there, so the best we have at ruling things out is narrowing it down to that one legendary battery. Oh, the battery, the infamous A07 battery. There is a good reason I conveniently left this out of the power section. Oscar 7's 6 amp-hour nickel-cadmium battery was what lies at the heart of the A07 story. So, being comprised of 10 individual cells and housed in its own sealed compartment, the battery of Oscar 7 was robust, and NASA tested, but it was nothing special for spacecraft. Plenty of NiCad batteries had flown on spacecraft before, with just about all of the Oscar craft using them at the time. All of them die the same way, increasing their electrical impedance, a combination of capacitance and resistance, as they age and fail. This has happened thousands of times, and all craft with these power sources will always meet the same fate, the battery starving the systems, or a final shutdown command as voltage drops from the dying cells. As far as the shutdown command goes, well, A07 didn't have one. The designers, being the clever and sneaky group they already are, designed A07 without one. They didn't want Oscar to quit. They wanted him to keep going as long as he could. Anyways, back to the cells. So, the impossible part about Oscar 7 is the failed open. When its cells enter the end-of-life process, that impedance, in essence, keeps trying to drain its power away more and more until the spacecraft fails. This is called failing short, like an exposed cable short-circuiting into the ground, giving the electricity an easy path to dissipate into the dead battery. When Oscar came back to life and failed open, this eliminated that impedance and allowed an easier path around its battery and to its systems. All that was needed was one open connection in one singular cell, and the battery would be bypassed. With this open circuit being much harder to jump the gap, if you will, this now left the electrons a straight shot into Oscar's previously mentioned systems. To create an equilibrium to this unintentional circuit, once the charge in these electrons was used up, they would now flow through the body of the spacecraft itself and back into its solar panel, passing up that harder path and completing its new and now much easier loop. As well as this, because of Oscar's build, and the fact he is already hardwired to operate without power-based memory or logic, means that, once Oscar had sufficient energy from his solar panels, he would power himself on and take his place in history as the world's one and only zombie satellite. It simply cannot be overstated here just how much of a legitimate, documented, and baffling mystery Oscar 7 truly is. He is an enigma, a true, real scientific anomaly. Theories have been put forth, yet all fall flat. Battery charge regulators, wiring issues, equipment failures, all have been ruled out. Everything on Oscar is fine, except for that battery. Even after 3 rounds of pre-flight testing done by NASA themselves and to the highest possible standards in the world, they had somehow, some way, missed something. Something so minute, so anomalous, and so microscopically small, it evaded every and all high-precision measurements available. A07, simply put, should not have happened. And, by every means we understand, it couldn't have happened. Oscar 7, this small, old, forgotten ham satellite, holds at its story one of the most significant scientific mysteries in the entire world. Not only this, but our man Carl, his PhD thesis is still ongoing. And as we know now, once he's spinning, he don't stop. So, there it is. Now you have the full story, the human story, and the story of Oscar 7. In closing, I'd first like to give a massive shout out to the legend himself, Oscar 7's project manager, Jan King, and the Vice President of AMSAT North America, Frank Karnauskas. Without them, this video simply wouldn't exist in the way it was able to with their help. Just about all the documentation you've seen comes from them, and I cannot thank them enough. The Oscar program has been a wild ride, and still is, with it continuing up to this very day. Made by students from the University of Maine, AMSAT is on its 122nd Oscar, launching on Independence Day or July 4th of 2024. The AMSAT A07 team and all of those involved in Oscar making those amazing, beautiful machines have my utmost respect and admiration. Their go-to attitude and sheer incredible skill is something to seriously behold. This video is very much dedicated to them, and, while some have sadly gone from this world, little Oscar will carry on their legacy, just as he does for us all. Well guys, hope you all enjoyed the video. As always, I want to give a huge thank you to anyone and everyone who's watched this. Just like the A07 team, this community and shared passion for these projects is what fuels me to keep going, and reminds me to never give up on sharing what I love. If you feel the same way, make sure you're subscribed to my channel for more forgotten spacecraft documentaries. I'm Ben, this is Retro Rockets, and I hope you have an amazing day.